Um, all right. Hello, everyone. Just remember that today is the first of the Advent of Code event. Let's see. Yeah, they started, and this is the first question. What is that? Okay, it's remaining 10 hours to the next one. There will be 12 days of puzzles, and hopefully the first one will be something that I can do easily. But it gives you the problem here. There is currently an issue with GitHub authentication. If it does not work, please try again. But um, to play, please identify yourself with via one of these services. Let's use GitHub, but I will need to do the following. Do this. Let you focus on my face for a tiny bit. Let me do this. I forgot my password. Let's see. Yeah. Mm-hmm. Okay. What? Uh, you gotta work, man. What's up? Why are you? Is it no? Yeah, I don't know. Let's use Google. Maybe it's connected to my Google account. Okay, I think we've got my email address right now. Let's go. Oh my god, what's going on? It's not working. Actually, the website already tells us that it is down, right? Why? Yeah, what am I doing? Maybe I can authenticate directly with Google then. Okay. Um, all right. Save. Anyways, I don't know. I'm in. I just want. All right. It's okay, I guess. All right. Let's see. If something happens, it happens. I can't control everything. So, um, day one. Advent of God. Day one. Secret entrance. The elves have good news and bad news. The good news is that they've discovered project management. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished as soon so that the other critical tasks can start on time. Alright, North Pole decorations, important. The bad news is that they've realized they have a different emergency. Well, according to their resource planning, none of them have any time left to decorate the North Pole. Oh my god. To save Christmas, the elves need you to finish decorating the North Pole by December the 12th. Right. Collect starts Collect stars by solving puzzles. 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Oh, so okay, 2 puzzles will be available on each day. The second puzzle is unlocked when you complete the first. Alright, each puzzle grants 1 star. Good luck. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. Let me in. A document taped to the wall helpfully explains, due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. Alright. The password is locked in the safe below. Please see the attached document for the new combination. Very professionally written. The safe has a dial. Okay, let's have a look at the safe before going to the attached document. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. Alright, like a clockwise thing. Alright, anyways, as you turn the dial, it makes a small click noise as it reaches the number. Alright, like these old landline phones. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with an L or R, which indicates whether the rotation should be to the left or to the right. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So if the dial were pointing at 11, a rotation of R8 would cause the dial to point to 19, right? Right 8 times. After that, a rotation of left right L19 would cause it to point at 0 because it starts from 0 up to 99. Okay, is it a circle? Yes, because the dial is a circle, turning the dial left from 0 1 click makes it point to 99. Similarly, turning the dial right from 99 1 click makes it point at 0. So if the dial were pointing at 5, a rotation of left 10 would cause it to, okay, 5, you're at the 0. 1, you're at the, so 5, you're at the 0. 6, you're at the 19. You have 4 left, so 98, 97, 96, 95. Point at 95, yes. After that, a rotation of right 5 would cause it to point at 0. The dial starts by pointing at 50. You could follow the instructions, but your recent required official North Pole secret ends to... Okay, let's start again. You could follow the instructions, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. I don't know what that is. What does decoy mean? Dude, please. I okay, anyways, actually, I don't know, maybe it's not that important. The actual password is the number of times the dial is left pointing at 0 after... Wait. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. Like it's pointing at... So there's like... So it's a circle. On the top it's 0. On the bottom it's half of it, 50, right? So if it's within the range of 51 to 99, it will... You will increase it by 1. Okay, but let's have a look. For example, suppose the attached document contained the following rotations. All right, let's see. Following these rotations would cause the dial to move as follows. The dial starts by pointing at 50, right? Left 68, meaning you are turning 50 to the left, so you become at 0, and then right to the to the right to 18, right? Wait more. Yeah, from the reverse. Okay, it's going this direction and 18. So, which means minus, basically, you do left 68 is like minus 18, which is you sum 100 to it, it becomes 82. And then left 30 means you minus 30, 52. Right 48 is to 0. Left 5, this. Right 60 is you put 5. Basically, you add them up and take a modulus of 100, right? And for this one, is it... yeah, if it's like left, it means minus 55, right? If it's right, you add it up. So if it's left, it's minus 1, modulus 100, it's 19. If it's minus 99, subtracted from 99, it's 0, right? And then right, it's like plus, modulus 100 is 14. And 14 minus 82 is... It is pointing at... So it's very, very difficult. 14 minus 82, right? So here did I do something wrong? Yeah, because of my... So you did first, but I don't understand. How come it's possible? From here on, you rotate it back at, like, you rotate, it's 14 and you rotate it back. Okay, so 14. Let's do, wait, no, it shouldn't. Because you take modulus and it's 32. Okay. it's the model polarization is there important, and it should be positive. Okay, so you do the subtraction or addition, and then you make, okay, if it's like minus, you have to make it positive and then take modulus, right? That kind of stuff. I don't know what's the best way to do that actually, but maybe I can just quickly draw it, I think. But let me continue. Because the dial points at 0 a total of 3 times during the process. Okay. Alright. Only times. Okay, only these times. The number of times the dial is left pointing at 0. What? Okay. The dial is left pointing at 0. Alright. Got it. What's the actual password? You will enter an integer basically here, right? So let's think about the, can I copy paste something here? Actually, yeah, okay, pretty good. So specifically, let's come up with an algorithm to do that. Shouldn't be too difficult. So you're starting from, let's is there something, can I change the color? Excuse me, yeah, okay. So you start from 50. So basically, independent from where you start, let's say you're at the x position x, you're going to do, if it's left, let's call lefts are y and rights are z, okay? And this could be right. And when you have this value, you have to do what? You can actually apply all the time some modulus 100 to them, because they can turn it extremely a lot of times, right? Like a lot of times. But the good thing is it won't be negative, right? So it can be 150, but it can't be minus 150. Left and right are being used for that. So for z, you can also take a modulus all the time before applying this formula. Take the modulus of it, and then you can check the result, and you will check, like, if, let's say this is a result, all right? If result is negative, just 100, right? If else if result is positive, actually there's nothing to do, just continue or like pass or whatever. And else if it is equals to the same, you'll just like, if it's equal to 0, sorry, you'll just increase the counter by 1, right? Plus, let's say. It's terrible, I know, but I think this will be the solution. Like, let's try. We are starting from 50, right? So this is 50, and y is here existing, it's 68. It's minus 18, and if it's like below 0, we put 100 to it, and it's 82, right? And then you take modulus of 100. Maybe you don't really need that, right? This you take it like for, if it's like higher than 0, then you can actually do that. You can do the take the modulus here just to be on the safe side, right? I think that's even clearer. So 82 we are at here, and x becomes now 82. Let's go and write it here. So x becomes 82. L30, so it's 30. It becomes 52, and if it's like bigger than 0, we take the modulus. It's okay. It's 52, and then we update to this one to here, and we have right 48, so it comes to the z part, right? And 48 plus 82, 52 is 100. It's also something for you to check, right? You can. I'm not sure actually. I'm curious. -10 modulus 100. Oh, it already does it. Alright. It's very easy then. Just ignore everything here. Everything. Just go away. We won't. We'll basically have this. Trust me, I'm writing Python for 3 years. But you live and learn, right? Yo, we got it. The result, and then we'll just check it. If it's like 0, we'll increase the counter by 1. If it's not, we'll live with our life. We'll leave on. But that's it. That's the algorithm basically. Now we have to write something to it. This will be our puzzle input, right? By the way, any edge cases that we can see? No, I don't think so. So what should I do? Should I just copy it, or like get your puzzle input, like download leaked file, yeah, to, I don't know, is there, what's the best way to download it? I'll just copy paste, not so bad. Let's open our cursor. Maybe you don't really need a cursor actually, but yeah, open a project. Let's do desktop, and here and advent of code, right? 25. Okay, interesting. If it Q1. All right, open it here, please. Give me a new file, q1py, and a new file, input.txt. Right, so we'll just read the input.txt, and yeah, we can store it. Thank you. Yeah, let's strip it, and we can put the value. Wells append. No, it's not an integer, but can we deactivate it? File toggle suggest toggle inline. Yeah, I think it's working. So you strip the lines, and you have the, it's not working. I have to do it, but yeah, let's see. how it will do. We got it. Then we can also parse it, right? We can say, okay, let's do it, and then we can split it by I don't know, line. You can. I'm just. Sorry, I'm a bit rushing. Disable cursor tab. Let's have direction and value and number. All right, and then we can. So this one will be line from 0 to 2. Oh no, what am I? Yeah, and this one will be starting from 1 to whatever, whenever it goes, and this one will be an integer. All right, and I'm assuming it's okay. They give the valid inputs. Assuming, I think this is the input, so we don't. There won't be any secret cases, right? Wait, what? What? Okay. Oh. Oh. Zen of Python. But like by importing, you do this. It's encrypted. Okay, I don't know. Thank you for this reminder. I don't know. You have the direction and number, right? And you can put it as tuples. Just like it. Maybe, I don't know. Yeah, maybe directions can be a list, and numbers can be a list, another list, and then you can directions that append direction, numbers that append direction number, and then you can print out directions, you can print out numbers. Good. And then you'll just have a counter. It will start from 0, and you'll iterate for I in range. Length of numbers, for example, doesn't really matter. You'll iterate, and current position will be 50, right? And you'll just have if direction I equals to left, you'll do something. Maybe like increment can be when it started, like, or I don't know. Maybe it's like current minus numbers I, and then you'll do result. Yeah, maybe we can do something. And then result equals to modulus of 100. All right, and that's it. Else, it's guaranteed to be R, okay? Let's assume it's like a very same. So you put the number right now, and you take the modulus. Perhaps you can do the modulus down here to not repeat ourselves. And as a result, here you should check if result equals to 0, you will increase the counter. If it's not, that's fine, we'll move on with our lives. And then I want you to print how many times we've seen 0. So I am not sure, like I think there won't be any floats will be involved this. It's just minus and plus. Modulus is also like, we'll do it in integer. So should be fine to run. And it's 32, dear followers. And I will indeed write it and submit it. That's not the right answer. Very bad. Unacceptable. 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 What's wrong? I know. I know. We forgot to say that, yeah, maybe you don't really need a result, right? It's just the current that you're moving with. So maybe you just need to do this, right? Do this. And then here you will do it for the current number. And then you'll check it like this. And that will be it. So you, yeah, this should be fine right now. A lot of times, but like, what was the, how many, what's the input size? Okay, acceptable. Return to day 1. It should be right now. Let's see. You're updating the current one as well. I mean, it's very important, but yeah, it happens. It's left, right, you, looks good. 995. Oh my god. Things are getting ugly. The first half of this puzzle is complete. It provides 1 gold star. I'm going to post this on LinkedIn. You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. You build a snowman, okay? Interesting. As you are rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to newer security protocols, please use password method 0x94 whatever until further notice. You remember from the training seminar that method blah blah means that you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. Alright. Following the same rotations as in the above example, the dial points at 0 a few extra times during its rotations. Right, true. The dial starts by pointing at 50. The dial is rotated left 68 to point at 82. During this rotation, it points at 0 once. And then 30 to the left, no, nothing. It points at 0, okay, increased again. This goes right, so you won't change something here because you already clicked at 0. Yeah, I think it's clear. In this example, the dial points at 0 3 times at the end of a rotation, plus 3 more times during the rotation. So in this example, the new password would be 6. Be careful if the dial were pointing at 50. A single rotation like right 1000 would cause the dial point at 0 10 times before returning back to 0, 50. That is important. That is important. All right, let's I gotta go, man, but I want to do it as well. All right, let's make it very small. I'm sure it will be okay. So let's maybe not so that small. Okay, the dial starts, but okay, let's have way. So first we have to do right now, we'll do this, let's have this formula back, x minus y plus z, right? Now you have to take into account of the following. You have to now do some kind of integer division. Of 100, because this will help, for example, here, right? If you do that for like right 1000, it will be 1050, and if you divide it by this, it will be 1000, like 10.5 or something like that. But like if you do the integer division, it will be 10, so it will cover that situation. So this is, now we are looking at the result of this one, I think, but I'm just not sure about this specific case. What happens if I do minus 10 integer division? I think that's the thing that we want. That's the thing that we want. Whatever the value is here, just do math, the absolute of it, right? It, for example, 180, right? Integer division. We should have 2, because that means right. Would it work? Let's go over the example. I think we have the example, we can work on it. So it's 50. Oh, it's terrible. Let's do this thing. We'll have 50 minus 68 plus 0, and it will be an integer division of 100, and we'll have the absolute of it to have the correct number, which will be pointing at, which will decrease, which will increase the counter or not. Okay, maybe you can do something like, first you can calculate this, and it will be minus 18, right? Perfect. And then from there on, you can say the current position will be minus 18 modulus 100, which will be 82. And then you will also do minus 18 integer division. The absolute of it should increase the counter by 1. By how much that it appears. So according to this, it will be basically counter will be 1. Alright. And then the next iteration will be the current position is 82. It's also left to 30 and 0, which becomes okay, it didn't autocomplete this time. It's 52 and current becomes directly 52. But yeah, imagine we are doing this like this, okay. And counter will be 52 division by 100, so its counter is still 1. Let's move on. My 52 plus 48, 100, current will be 0, counter will be absolute of 100 integer division, and the counter becomes 2. Let's move on. I think it's going correctly, right? The current position is 0, left to 5, right? It's minus 5. Minus 5. Current will be minus 5 modulus, whatever it is, it's 95. And the counter will be absolute of it, right? Absolute of it is like 1, so its counter will become 3, which is correct. And we have left one, 95 minus 1. No, sorry, it's here, right? 60. 155. Current will be 155 modulus 100. It will be 55. Counter will be increased by the integer division of it, right? So it will be increased by 1, which will make the counter 4. And left 55. I think this is working as expected. If we were to have, for example, from here, 55 to 1000, yeah, it makes this much, and current will be 155, 100, it will be 55, and the counter will be increased by 55, integer division of 100, which makes it 10, right? I think it should be okay. So the same input, now you would like to change it to q1.pi, or like, yeah, we can do it like this. Oh, sorry. So it will be, the logic will be the way that, okay, you're doing this minus and plus thing, and then, yeah, you can do it as well here, but you can also store you can increase the following like this, yeah. And then you can do this operation, update it. That's it. We can have our test one as well, test input, right? And it will be as file lines, file read lines, and the test input could be this one, but can we have it? Do we have it? We don't have it, right? Let's ask cursor to do it. Like we have in input.txt. All right, so that we can test it out, and we are expecting 6, right, in that case. So this code, in this case, should work fine. I do believe. Let's see. R48, L5, R60, L55, L1, L99, R4. Yeah. All right, we're all writing it, right? So it's okay. We can do it. It's 6, right? That's true. Okay, then let's comment this thing out. And yeah, seems to be like it. Go. That's not right. Your answer is too high. My answer is too high. Too high. What am I missing here? Can I read the question again? Yeah, that's what we do. We divide by 100, which makes it 10 times, right? That's the thing that you want. Any click, count the number of times any click causes the dial to point at 0. Yeah. I don't understand. what's something is missing. Something is not right. I really don't understand. Do you have hints, tips for me? If you have any, just let me know. Yeah, maybe I need to think more. What is this comments about? Like, what is this? I unfortunately don't understand. The tips in yeah. All right. Any tips, Iro? There's a latency. Oh my god. All right. All right. Anyway, so let's stop with here. I think it's just something is something is missing here, but I couldn't understand. I don't want to ask it to cursor as well. I will think about it.